Hi, hello. So in this video, we're gonna have a crash course on quadratic functions and graphs. So to start off, right, let's talk about what a quadratic function is. So I wrote down here y equals to ax squared plus bx plus c. So this is kind of like a generic form of your quadratic function lah, right? So you have x squared term, you have an x term, you have a constant term. Of course, sometimes the x term might be missing, sometimes the constant term might be missing, but the idea is that when we have the x squared term, right, when the highest power of your x is 2, that classifies it as a quadratic function. Okay, now when you write it out in this form, what we have here are we can separate them into the different terms based on what x values what powers of x we have, right? So we have x squared, x, and then a constant term. Okay, so instead of highlighting those, let me highlight the coefficient a, b, and then the constant will be c, right? So we use these letters to represent, we learn algebra, right? So we use letters to represent unknowns or variables. In this case, they're unknowns, right? They're not variables. It's just that these numbers can be anything, can be positive number, can be negative number, could be any kind of real number, right? Can be something with decimals, something with a square root, things like that. Okay, anything. So these are just, in a sense, they are just numbers. Okay, we don't need to care too much about them, except when we do questions on quadratic functions, right? When we want to look at what kind of quadratic curve does it give us, is it okay? So most students will remember this as, is it a smiley face graph or is it a sad face graph, right? So what we need to focus on is this coefficient of the x squared term, which is why I wrote down here. Okay, that's the first part of today's for this video, right? Today's lesson. Okay, I'm going to skip ahead first. Okay, instead of going through this part, this is just a kind of like a teaser, just an introduction. Okay, but now I want to talk a bit about what we are going to go through today and what are the things that I'm going to cover. Then we're going to dive into some content, and then I would say one very complete example of most of the concepts that you can be tested on related to quadratic graphs. Okay, so the breakdown is as such. Okay, first part we're going to talk about is the coefficient of your x squared term and what it means. Next one is your maximum and minimum point, right? If you have a quadratic graph, your quadratic graph will look like, okay, actually let me just quickly go through here, because since we are talking about coefficient of x squared term, we can look at the coefficient of x squared term and break it down into separate them into two cases, right? When the coefficient, okay, let's call it a, is a positive number. Okay, it's a positive number. Okay, versus when it's a negative number. When it's a positive number, you can think about it as you're feeling positive, right? When you're feeling positive, it's a smiley face. Okay, so it's a smiley face curve, or it will look something like this. The axis might be a bit different depending on what your specific quadratic function is, but it will look like a smiley face curve like this. Now if your coefficient of x squared term is negative, that means you're feeling negative, right? You're feeling sad face. So you will get a sad face curve. So maybe sad face curve, maybe I just anyhow draw the axis, right? The axis can be anywhere depending on your quadratic function, right? It depends on all these coefficients. But the main idea that we need to know, okay, is when the coefficient of x squared term is positive versus when it's negative, we have smiley and sad face curves. Okay, why is this so important? The most important part about knowing whether it's a smiley face and sad face curve, I think, okay, the most important part is to figure out whether it has a minimum or a maximum point. all quadratic curves, okay, all quadratic curves will have a turning point. That means the curve will go down, go down, go down, go down, then it will turn around and go back up. Or it will go up, go up, go up, and then turn around and go back down, right? So there's a maximum or a minimum point, depending on whether it's a smiley face or a sad face curve, right? So we need to know the nature, we need to know the shape, so that we know whether we are looking for maximum or minimum. Okay, that's the story behind it. But actually, when you do the math, when you do the workings to find the minimum or maximum or minimum, okay, the steps are the same. Okay, you don't really need to care about whether it's minimum or maximum. In a sense, the algebra that you're gonna do, the workings you're gonna do, is the same. It's just that usually questions will ask you, is this a minimum point, or is this a maximum point, or they ask you, does this curve have a minimum or a maximum point? So you need to know, right? It's just that you need to know, but then when you are trying to find out where is this point, what is the coordinates of this turning point, you don't actually need to care about whether it's maximum or minimum. Okay, so for maximum and minimum, if you sketch out a smiley and a sad face curve, okay, you can see that the smiley face curve has a minimum point. The sad face curve has a maximum point. So over here is minimum point. Over here is maximum point. Okay? Yeah, so minimum and maximum depends on whether it's a smiley or sad face curve. Otherwise, you can just call it a turning point. Okay? You can call it a turning point. Okay, because you don't really need to, I don't think it's very, very important to know whether it's a minimum or maximum if you're just doing, in a sense, you're just working through the algebra to find the answer. But it's oftentimes good to at least have some idea lah, okay? It's good to have some idea, it's good to sketch out the curve, even if you are not asked to sketch out the curve, even if you are not told to graph it out. I think it's a good idea to have some mental image, right, of what it might look like and what you're trying to find. Okay, so always try to sketch out little curves at the side, you know. Maybe if you want to like find a certain intercept, try to look for it on this little sketch. It's very important to try to visualize. Okay, next concept we're going to talk about is symmetry, right? If you sketch out so again, I'm going to sketch it out. Maybe I sketch out something like this. So I'm gonna work with this like very, very perfect quadratic curve, right? So this very, very perfect quadratic curve is just because the turning point is at the origin, and this is y equals to x squared. Okay, what do I mean by symmetry? When I talk about symmetry, or when I talk about line of symmetry, actually, let me write down. Let me add here. Okay, line of symmetry. It just means when I graph out this quadratic curve, right? When I graph it out, a graph is a picture lah. So basically, what I'm doing is I have this equation, I have this function, I have an equation. I'm gonna graph it out. I'm gonna look at how does it look like visually. What is the picture of this curve, right? What is the picture for this function? So this is a picture, and I want to ask, right? I want to ask, how can I fold this picture in half such that the two halves overlap exactly, like mirror image, right? Where can I fold? I realize that if I think a little bit, I sat here for a little while, I realize that if I fold along the y-axis, right? If I fold along the y-axis, so let me just draw a dotted line. So if I fold along here, I will get another overlap here, right? Mirror image is symmetrical about this line. So a lot of times you are asked, or you will be asked to find, okay, not will, a lot of times you may be asked, okay, to find what is the line of symmetry. Okay, that means where should I fold so that I get the same overlapping image. Okay, so now that I sketch it out, it's very easy to see, which is why I encourage you to sketch it out. Second thing is, after I sketch it out, I realize that it's just the y-axis. But how do I phrase my answer? How do I present my answer? I can't just say y-axis, right? I mean, technically you can, but usually they'll ask for the equation of the line of symmetry, right? So equation means like something equals something. So how can I write it down? Okay, so first thing you need to recall down here in pink color, okay? You need to recall that equation of a y-axis, okay, is x equals to 0. Why? Because your entire y-axis, okay, any point on the y-axis has a x value of 0. Right? See, your x-axis is over here. This is x equals 0. Okay, and anywhere along your y-axis has x value 0. So equation of y-axis is x equals to 0. Okay, now same thing. Okay, similarly, your equation of your x-axis, this entire axis here, okay, this entire line here, is y equals to 0. Why is this so? Because your y value, okay, y value equals to 0, or rather, the entire x-axis has y equals to 0. The y value is 0. So this is how we describe lines. Okay, how we describe lines. You need to be very good at, in a sense, you need to be very good at naming vertical and horizontal lines, because this will be quite important in our line of symmetry, especially vertical lines, because not usually, but for O level, N level, we only talk about quadratic curves that go kind of like up and down, up and down. We don't look at quadratic curves that go left and right. You haven't seen that before. Okay, so when it's up and down, right, or like smiley face, sad face, you can only fold left or right, like left to right. So your line of symmetry is going to be vertical. That means, for example, if I draw a slightly different curve, right, slightly different curve, I'm going to almost the same. I'm just going to shift it to the side. Shift it to the side like this. And when I shift it to the side like this, I can see that my line of symmetry has shifted also. My line of symmetry is now here instead of the y-axis, right? So how can I name this? How can I name this line of symmetry? Let's say I find out that this x value, okay, where I draw the dotted line, right, it cuts the x-axis, right? Let's say I find out that the x value is k. Then this dotted line, I can write down the equation of this dotted line as x equals to k. So let's try to understand this a little bit deeper. What does x equals to k tell us? It tells us that this line is simply a collection of every single point on your xy plane, every single point where the x coordinate is equals to k, a certain number. Let's say k equals to 2, right? Then that means any point where it's like, where your coordinates is 2 comma something, 2 comma something, 2 comma something, any of these points, they must lie on this line. X equals to, in this case, x equals to 2. Okay, so x equals to k describes any point, okay, or the collection of all of these points where the x coordinate is equals to k. That's how we name vertical, horizontal lines. Now what about, like, in a sense, slanted lines, right? Or like not vertical, not horizontal, other kind of lines. That one you have learned before in your, your linear graphs. Y equals to mx plus c, right? So I'm just gonna write it down, maybe at a corner over here, maybe at the top left corner. Okay, so I'm gonna write down here to recall, okay, linear functions and graphs. right? So something like what we are going through today, except today we're going to go through quadratic, but you need to know a bit of your linear function and graphs. So linear functions usually look like y equals to mx plus c. This is the form that we like to write it as. That means, let's say sometimes we get like a 2y equals to something something something. We will try to divide by 2 throughout. So there is y equals to some number times x plus some number, or minus some number. Okay, so we prefer this form. Why? Because when we write it as this form, we get something neat. We get this number, whatever it is. This is the gradient. What else? This c, okay, it can be a negative number, so think of it as, let's say it's 2x minus 2. Then what is my c? C is negative 2. Okay, so just pretend like it's always plus. Pretend like, you know, c can be whatever number it is lah. So if you write it as something x minus 2, you can rephrase it, okay, put brackets and say that it's 2x plus negative 2. Then c is negative 2. Okay, in this case, what does c represent? C represents y-intercept, which means where your straight line, okay, where your straight line cuts the y-axis, or the y value in which it cuts the y-axis. Okay, so this is just a quick recap of your linear functions and graphs. We have, in this form, we have something neat where this number here, whatever it is, can be again, it can be positive, negative, decimal, fraction, square root, I don't care, anything, okay, any real number here, okay, but this represents the gradient and this represents the y-intercept. So we have, in a sense, we have like 3 different types of straight lines, right? We have this y equals mx plus c. We also have the x equals something, y equals something. Okay, so we need to be careful about all these lah. I think because this video is just a crash course, I'm not going to dive too much into trying to like visualize or picture it, or understanding very deeply. Okay, I want to go through things that can earn you marks in your exams. So I'm not going to talk too much about the details. I'm just going to focus on the things that can earn you marks. So let's try to move on. Okay, let's try to move on. Line of symmetry to rehash. Okay, line of symmetry is basically when you have a graph of your quadratic curve. Where can I fold the graph into half exactly? Like, where can I fold so that the graph just overlaps itself, right? Where can I, in a sense, where is the dotted line where it looks like it's a mirror image on both sides? Okay, so line of symmetry for quadratic curves, okay, in O level N level, okay, your quadratic curve is going to be smiley face or sad face, which means you always fold left to right. So your fold or your line of symmetry is a vertical line. And vertical lines are usually in the form of, not usually, but they are always in the form of x equals to a certain number. Okay, and that number is where the dotted line, where it cuts the x-axis, or your x value. Okay, next part, and last part. Okay, last part. The last part of this this crash course, I'm going to talk about how we can, or how you are usually tested for this kind of graph questions, right? Usually there's this slightly harder problem, okay, where they give you an equation, right? They give you an equation and they say, how can I solve this equation using a graph? And this equation looks something like what you're given for your quadratic curve, right? Something similar to, let's say, maybe 2x squared, right? Something like that. But maybe it's like 2x squared plus something equals to 0. Then it asks you to solve it using a graph, right? It looks something like what you're given at first, but it's slightly different. And then you have to figure out, how can I use these two, or how can I use my previous graph that I plotted plus something else. How can I solve this question, right? So the idea is that this kind of problem, what they are doing is they're asking you to think of a new graph, think of a new line. Usually it's a straight line. So think of a new line that you can graph it out, you can plot, right? So now you have a curve and a line, and you just want to find the points of intersection, basically where the two lines, the line and the curve cuts. Okay, and this will give you the solutions to some equation that you're given. Okay, an example. Let's say in part 1 of a certain question, I am tasked to graph out a curve. So I fill in my, my x equals to, so I write down my x, what's it called? Table of values, yes. Okay, x, y, and then I write down my numbers, whatever. Then I plot out a curve, right? Plot out very nicely. I draw very neatly, and I get this quadratic curve, right? Nice looking quadratic curve. Now they give us some equation, and they say that, okay, you need to use this equation, you need to think of a line to plot, then you can solve this certain equation, right? So maybe I think a bit, and I do some workings. I realize that I need to plot a certain line, maybe y equals to 2x, for example. Okay, so what I'll do is I will again write down a new table of values. Okay, maybe -3, 0, 3, or whatever, right? Example. Okay, so now I'm going to sketch out, I'm going to draw out y equals to 2x. Okay, let's say 2x plus 5. Okay, so let's say I sketch out 2x plus 5, and I see that is like maybe like this. Okay, now how does this help me? How does it help me solve an equation? Okay, the equation, of course, this is just a general example. I didn't give you what the equation is, or I didn't really give you the equation of this quadratic curve, but we're just assuming, right? We're just looking at like a general question. This is usually how you're tested, and if you know how to approach this question, whatever numbers they throw at you, they're just numbers. You can deal with them. Okay, so don't need to worry about it. The idea is usually when you're given an equation, they ask you, what can you do to solve it graphically? The answer is usually, I need to plot a new line, or I need to plot a new graph, whatever graph it might be. So you need to figure out what that graph is, or what the function is. You need to write down your table of values. You need to plot it out. You need to draw your line. Then, last step, okay, easiest step, is to find where they intersect, these 2 points. Then what's your answer? Your answer is the x values. And that's it. I think that's the hardest question that they can test you for quadratic graphs, right? So usually the flow is like this. They'll ask you things like, I have a quadratic function. Let's say something like this. Quadratic function, right? They write down in the equation y equals to something, x squared, and then maybe some extra stuff. Okay? So is it a smiley face or sad face curve? Okay, they don't ask like that lah. Okay, they don't use smiley and sad face. But sometimes they'll ask things like, does this quadratic curve have a maximum or a minimum point? So what do? You check for the coefficient of x squared term. If it's positive, you're feeling positive, it's a smiley face. If it's negative, you're feeling negative, then it's a sad face curve. Now that you know whether it's a smiley face or a sad face curve, you need to figure out, how can I find out the turning point? Okay, turning point is either maximum or minimum. If you know whether it's a smiley or sad face, you'll know which one it is. How to find it out, later I'll go through one solid example. Okay, not solid example, but more of like a worked example, right? So I'll give numbers, I'll work it out for you. You can tell how to apply it. Okay, yeah, okay, poor choice of words. Okay, so we need to know how to find out the turning point. Okay, either maximum or minimum point. And usually they will also couple this with another part. What is the line of symmetry? That means, how can I fold? Where should I fold to get the same picture? Right? Basically fold the graph into half. Last question, okay, or last group of questions is, I give you an equation, I want you to use graphs. Okay, use graphs to solve it. Now, to use graphs to solve it, that means I need to draw something. I need to plot something on a graph paper, right? But usually I already have my quadratic curve plotted out. I need to plot something else. So the difficult part is, I think the difficult part is mostly just understanding that you need to plot something else, and how should you find out what to plot. Once you know how to plot, it's just graph question, right? I think graph questions should be quite simple. If they give you y equals to 2x minus 1, put in some values of x, you get some coordinates, you get some points, plot it, then take a ruler and draw a line through all the points, right? Very simple. So this one, I think everyone has been doing it since like sec 1, sec 2. So not too difficult, but the idea is that you need to know that's what you need to do. Once you know that that's what you need to do, how to do it, quite simple. I think most people will remember how to do. Okay? So let's move on. Okay? I think I drew these two pictures here just to show that, positive, negative, then it will be smiley face and sad face. But we've talked about it already, so we're gonna move on. Okay? Actually, let me just erase this so that it's not so confusing, and we don't really need it anymore. Okay? Next page. This is, I think, the more, I think you need to look through the workings. So I wrote it out nicely. Hopefully my handwriting is nice enough for you to, for anyone to understand. Okay. Yeah. So let's say I'm given, y equals to x squared minus 6x. Okay, same for both sides. And I want to find the minimum or maximum point, the turning point. How can I find the minimum or maximum point? First way that should work all the time, is completing the square. So if I'm given quadratic, right? If I complete the square, what do I get? I get something like this, right? I get a square and then either plus or minus some other number outside. Doesn't matter, ignore that. Okay, not ignore that, just leave it there. Okay, leave it there. Okay. Now the idea is, if I want to minimize or if I want to maximize something, the idea is that, okay, for example, in this case is to minimize. Sorry. Okay. In this case is to minimize the function value, right? Or this equation basically. Okay. Something square minus 9. If I want to minimize it, what does it mean? That means I want to look at, okay, there's two parts to it, right? There's this part, and there's this part, right? The red color and blue color. Hopefully you can see the highlight. Okay, there's a red color and blue color part. Which one can I change? Minus 9 is just a constant, right? I cannot change the value of minus 9. So that's useless to me, right? I want to minimize it, right? I want to find the minimum point, but I can't change this 9. So leave it alone. I can change this value, right, of the square by substituting different x values. I can change this value and I can make it as, in a sense, I can make it as big as I want, but I can't make it as small as I want. So what is the minimum value for this square part? Any number squared will be a positive number, right? Except 0. If I sub in some number to make sure that everything inside the bracket is 0, then this thing just becomes 0, and what's left is negative 9. If I sub in any other number, right, inside the bracket, okay, I don't care that it's x minus 3, just some number inside the bracket. If it's anything except for 0, I will get a positive number. And positive number minus 9, okay, whatever lah. Basically, the number, in the end, okay, the y value will be bigger than negative 9. Negative 9 is the minimum value. Okay? So to rehash, okay, to make it more clear, the idea is just like this. After I complete the square, I have two parts, the square and some number. I cannot change the value of the number. I leave it alone. right? Don't erase it, don't remove it, just leave it alone, right? Don't touch it, it's there, but I don't need to do anything with it. Now this square part, this square term, for different values of x minus 3 squared will take up a different value. If everything inside the bracket is equals to 0, that means x minus 3 equals to 0, then the whole thing will be 0. The whole square will be 0. It will be 0 minus 9, negative 9. Now you can play around with your calculator, sub in different values. If I put in anything else, okay, don't care that it's x minus 3, just put a number inside the bracket. Any number squared minus 9. Any number, you realize that the whole thing will be bigger than negative 9. The smallest is when you sub in 0 to this entire bracket, squared minus 9. You get negative 9. So once you get the example, okay, or get the explanation, it's very simple. Complete the square, then make sure that the square is 0. Basically, consider x minus 3 equals to 0. That means x equals to 3. You take this, sub it back in, okay, sub it back all the way back into the original one, okay. So x equals to 3, you sub it back in, you get 3 squared minus 6, 3 times 3, sorry. Okay, then you work it out, you get y equals to negative 9, which is as expected, right? We talked about how if we minimize the square, if we let the square term become 0, what is left is negative 9. Exactly, it's the same. So it checks out, right? So this is your minimum point. The minimum point is given by letting your square term be as small as possible. As small as possible. Okay? So your minimum value of y, minimum value of y is the square term equals to 0. Everything else is the minimum value of y. What is your value of x? You need to find out. Value of x is when this thing inside is equal to 0. Then you solve for x. Okay? This method, I think, I rely on this method a lot as a student because it has never failed me. Okay? So this method of completing a square, I think it helps you revise a bit of your completing a square as well. Yeah, you just complete a square, then you sub here, sub there. In a sense, you know, it's just algebra, right? Yeah. Okay. The other method is you can find the average of the two. Okay, I can't really zoom and scroll to that side, but you can just focus on this side. Okay. Second method is average of two roots. So what are roots? Roots are basically when or where the curve intersects the x-axis. So I'm going to write down here, when y equals to 0, what does this y equals 0 mean? Y equals 0 is x-axis. Okay, recall. X-axis is y equals 0. Y-axis is x equals 0. Okay, this one must know. Okay, so now what do I mean by average of two roots? First thing is I need to find out where does the curve cut the y-axis. Where does the curve cut the x-axis? Okay, so I sketch it out. Okay, I sketch it out. Let's say I'm a student, right? And I don't really know how this graph looks like. First thing is I look at the coefficient of x squared. There's nothing here, which means it's a positive 1. Positive 1, positive, right? Feeling positive, smiley face curve. Okay, smiley face curve. I don't really know, where is the axis and, whatever. I'm just going to pretend like the x-axis will be cutting through like here. Okay, so now if I do that, I know that my two roots are just here and here. And what is my turning point? My turning point is here. It's always right in between my two roots. Okay, so what I'm doing is I'm finding the average of the two roots to find this x coordinate. okay? And then the y coordinate, of course, I need to find out afterwards, okay? So, to find out the average of two roots, first thing is I need to find the two roots. To find the two roots, I sub in y equals to 0 to find out where the curve cuts the x-axis. I realize that is x equals to 0, x equals to 6. That means my two red color numbers, 0 and 6. So what is the middle? The middle is whatever these are, okay? Don't care whether positive number, negative number, decimal, fraction, square root, I don't care. Doesn't matter. They're just numbers. So this, okay, sorry. This number, okay, this number plus this number, okay, I put down here in brackets, over 2. That is the average. And that's where you will find your turning point. In this case, it's a minimum point. So I say minimum point occurs when, and then I find this. So now what else do I need to know? I need to know the y coordinate, right? I need the x value and the y value. The x value I just found out that is 3. Y value is when x equals to 3. I sub back in. And I realized that actually, hey, I've done this before, right? I look at this on the other side. You can tell that these last few steps of workings, they're the same. Okay, they're the same. The only reason why the left side is a bit longer is because I wrote down some words, right? Technically, you can just skip from here. So the only parts of the working you need to write is up till here, okay? And then you can continue from here onwards. Okay, you can skip this entire chunk of words. You don't need to write it lah. So it's technically it's the same length. Okay, you see which one you prefer. But I will say, although the method 2 seems a bit easier, completing a square always works. Okay, completing a square always works. To share why, okay, I'll just briefly share why. One example to show why completing a square will be better is sometimes your curve doesn't even touch the x-axis. So sometimes your curve will be like this, floating above the x-axis, or maybe touch the x-axis once. Ideally, you will cut it twice and then you can find the center, right, for your turning point. But sometimes it's like this, right, a bit weird. Then in the first case, you can't even use this method. There's no roots, it doesn't cut. In this case, you will get one root. Then if you realize that if it's one root, that means that's the turning point, right? That's where the turning point is. Then okay lah. If you understand, then you can continue with that. But if there's no roots, you get stuck. Okay, so my advice is try both methods. During practice, try both methods. Okay, they are not too difficult. Anyway, completing a square, I think, quite easy to remember. If you don't remember, then this is a good chance for you to practice your completing a square. Okay, so finding minimum and maximum point like this. Actually, right, this entire page, other than to use it to find minimum and maximum point, second thing that you can use to find is actually the line of symmetry. I'm going to write in green. The line of symmetry is already found. Line of symmetry, where is it? X equals 3. Okay, so why is it so? Line of symmetry is a vertical line for our quadratic curve, right? And the vertical line is described by x equals to something. X equals to something. Okay, so x equals to what? What should this x value be? The x value is just where you fold your graph, right? The line of symmetry is basically where you fold your graph. Think of it as origami, right? You fold your graph paper. So you need to fold it where the graph turns. You need to fold it where your graph turns, right? Your graph turns, and then here, it turns here. So you're going to fold it along this dotted line, right? Vertical dotted line. If you fold it, you get the same thing. Right? You get the same thing. So it's symmetry, right? So when you're finding the turning point, first thing you find is your x value. When you find your x value, what you have gotten is actually you have gotten the line of symmetry. So this technically it's finding minimum, maximum, as well as line of symmetry, killing two birds with one stone, right? Okay, so if you just want to find the line of symmetry, then you can stop here, right? It's still the same method, but it's just stop here. You don't need to continue. But if you want to, or if you're asked to, you can continue, substitute back into the equation to find your turning point. Okay, that's actually all for the content I want to cover. I want to go through one worked example. So I wrote down the question here. Actually, I come up with this question on my own. I don't want to go and steal from different schools. I don't really know if I will get into trouble for copyright or anything. So I just come up with this question on my own. It's like a full question. It's a very full question. So let's just quickly talk about it. I will scribble down the workings at the side. But if you want to do it, if you want to go and practice this entire question on your own, please try. But I'm not going to work out all the answers. I'm just going to point out how should you tackle it, how should you approach. Okay, so let's start off with first part. Does this graph, okay, does this equation or function, whatever you want to call it, okay, so does this graph y equals to 4 minus x squared have a minimum or a maximum point? Okay, does this equation have a minimum or maximum point? Okay, by right it should be called function. Okay, function. Does this function? Okay, so I say anything because whether you know the word or not, it doesn't earn you any marks in exam. Okay, it doesn't matter. But I know by right it should be function. Okay, function. So does this function have a minimum or maximum point? How do we tell? Y equals to 4 minus x squared. Sometimes if you think about some math problem, if you don't know what to do, you write it big on a piece of paper or you write on a whiteboard, right? Usually the bigger you write, easier the answer will come to you. Okay, so you look at this, okay, x squared. Then remember, if I know the coefficient of x squared, right, the a, right, I will know whether it's smiley face or sad face. But in this case, x squared, there's no number in front of it, but it's negative sign. That means this is like saying plus negative 1 times x squared. I know this is very weird, but this is very messy. But yeah, okay, something like this. So what is your coefficient? Negative 1. And negative 1, okay, so your coefficient, okay, coefficient of x squared, okay, is negative 1, okay, which is less than 0. Okay, so since it's less than 0, what do you have? Less than 0 means negative, right? Means you're feeling negative. Feeling negative means sad face curve. Okay, sad face curve. So sad face curve got minimum or maximum? Sad face curve has a maximum point. So the answer should be maximum point. Okay, now find this point. Okay, fine, find this point. Okay, how do we find this point? There are two methods, right? Two methods. I prefer completing a square. Completing the square. But now I'm going to show you a different way. Completing a square always works. It's just that completing a square sometimes it takes a while, right? You need to go through the algebra, go through the workings. So there's another way. The other way is just to factorize and find roots or find a solution. Okay, so what do I mean by this? Y equals to 4 minus x squared. Okay, factorize into 2 minus x, 2 plus x. Is the a squared minus b squared, where your b squared is x squared, a squared is 2 squared. So you get this. Now when you let y equals 0, okay, let y equals 0, what do you get? You get 2 minus x equals 0, or 2 plus x equals 0. So x equals to 2, x equals to negative 2. Okay, so these are your two roots. What does that mean? That means on my sad face curve, Okay, let me remove the eyes. It will look very weird. Okay, so if I remove the eyes, so I'll get something like this, right? My x-axis will cut through here. Maybe this is -2, this is +2. How do I find my turning point? My turning point is right in between these two numbers. So I need to find the average of those two. Okay, so I need to find the average of those two. Let me make this smaller, so I got a bit more space to write. Anyway, when I send in this video, if you want, you can pause it and then zoom in or something. Okay, so how do I find the x value? So at the turning point, or in this case we can say maximum point, okay, comma, x is equals to the average of those two, right? -2 plus +2 divided by 2. I realize that the numerator will become 0, so the whole thing is just 0. Okay, 0. So when x equals 0, what is y? Y is 4 minus x squared, by 0 squared. So y equals to 4. Therefore, maximum point is 0, 4. Done. Okay, I know I say I won't go through all the answers, but yeah, sometimes I end up doing anyway. Never mind. Then you get the solutions here. Okay, like this. Now, next one, I think quite simple, right? We have done it already, actually, right? So, okay, fine. Part 3, I won't do, okay? The answer is already somewhere here. You just need to revise a little bit, think about it a little bit. Where is the line of symmetry, right? We have gotten the answer already, somewhere. And make sure you write down an equation, line of symmetry. Okay, write down the equation of the line of symmetry. Okay, so by right it should be phrased like this. So write down the equation of line of symmetry. Okay, so yeah, so we actually have found it already. You just need to write it down, and it must be an equation. That means don't go and write some number, right? Equation, something equals something. Okay, part B, of course, I'm not gonna do it. Okay, I don't have graph paper, and also I don't like to draw graphs. So plot the graph of this for this range of values. What do you do? First thing is I'm just going to help you with the table of values. Okay, so for quadratic curve, how many values should you have? Okay, so to recap a little bit, for linear graphs, okay, versus for quadratic graphs, for curves. Okay, for linear graphs, we try to have 3x values. For quadratic graphs, we try to have 5x values. Okay, or basically 5 or 3 and 5 points or plots, okay, respectively. Okay, so in this case, what we're going to do, okay, let me put this aside. Okay, what we're going to do is we're just going to write down the table of values. So x and y, I'm going to write down -3 and then all the way until 3, right? So I'm going to pick 3 numbers in between. I'm going to write maybe 0. Maybe I'll go and put -1 and 1. I can pick other numbers as well, doesn't really matter. I just want to space them out nicely lah. Okay, space them out nicely. Okay, then what I'm going to do is I'm just going to sub each value in, right? -3 sub into the equation, what do I get? -1 sub into the equation, what do I get? Things like that. I can fill up the blanks. Okay, so what I have is over here like this, 5, 5, -3 will be -3. Okay, something like this. Okay, so now that you have this, you just need to plot 1, 2, 3, 4, 5 points. Then you'll plot on your graph paper. You'll get something like, maybe your graph paper is like this. Okay, you draw your axis like this. Then you have dot, dot, plot, plot, plot. Then you draw a curve. Okay, so you just need to draw very nicely lah. Okay, so your yeah, be careful with, okay, with your graph. Be careful with your table of values, because if you make a mistake here, you get some weird plots. Your graph might look just, you'll just be wrong. Okay, you'll just be wrong. Okay, so usually for these kind of things, how do we get these values? We get these values by picking some x values, we sub into the equation, right? Which means all of these points must lie exactly, it must lie perfectly on the curve. That means if you plot, and you realize that if you put down your curve ruler, you draw freehand or whatever, I don't care, okay? And you see that some points are impossible to go through the curve, right? It's impossible to draw a nice curve through your points. That means you probably made some mistake. Either you made a mistake in calculating these values, or maybe you made a mistake in plotting them onto your graph paper. So you need to check. They should be perfect. Okay, they should be perfect. Okay, now the hard part. Okay, part C. Consider the equation, this one, right? Okay, then write down the equation of a line, okay, that can be plotted on the same graph paper to solve this equation. Then part 2 is solve the equation graphically. That means use your graph to solve the equation. Okay, so consider this equation. Okay, I'm gonna create some space here. I'm gonna annotate a little bit. So what do I mean by consider this equation? In fact, how do I use this equation at all? Wait, I'm supposed to change the 6 into a 4, but I forgot to change this 6. So by right, the answers for this are different. Okay, but anyway, okay, I'll erase this and then I'll rewrite very quickly. So this will be 4, this will be 3, and then this will be -5, -5. Okay, yeah, but nothing changes for the method. It's just that I changed the number here so that this is a bit easier to do. Not easier to do. This is a bit easier to do. Okay, anyway, consider the equation and then I give you this, right? So first of all, what do? First thing is I had 4 minus x squared. Where is my 4 minus x squared here? It's over here. So what does that mean? That means I have some extra thing here, right? Throw to the other side of the equation. It's always that simple. Okay, pull back out your 4 minus x squared. Pull back out your original function. Everything else throw to the other side of the equation. So I have positive 2x on the other side. Now what does this mean? This means I have two graphs. This is my first graph. Let's call it y1. Okay, y1 equals to 4 minus x squared. Okay, the other one is y2, second graph, which is equals to 2x. I've already plotted this. I need to plot this. Okay, plot this. So first step is to plot this other graph. Okay, plot this other graph. Find points of intersection. And that's it. I'm done. Actually, this is not just part 1. This is part 2 also. So what is part 1? Write down the equation of a line. The equation of a line is, the answer is y equals to 2x. That's it. It's basically this equation. Okay, now part 2. Hence solve the equation graphically. That means plot this other graph that we wrote down. So what do we have to do? We have to put down our table of values, right? We have x, y, maybe we put -3, 0, 3. Because it's a straight line graph, we don't need that many values, we only need 3. So we write down, and this will be -6, 0, 6. Then we plot our graph. So now let's say I plot our graph and we get something like this, What do? I just look at these 2 points and I read the x value. Okay, x value equals to what? So these are my solutions to the equation y equals, sorry, not y equals, 4 minus 2x minus x squared equals to 0. Okay, basically we have answered the original question, part C. Okay, so I'll give you the final answer. I think it's important that you try this part C out, okay, because this is, I think, the hardest part of what we went through today. So try this question out. I'll give you the final answer. The final answer, okay, let me see. The final answer should be, okay, I don't think I can do it here. Wait, hold on. Pause for like 1 minute. Because if I do it here, then I'll give you the final answer. I'll give you the workings, right? So let me just quickly find out answer. Okay, so I just write down to 3SF okay. So the answer, okay, so the answers for C part 2, okay, x equals to negative 3.24, x equals to 1.24, okay, to 3SF. So of course, if you graph it out, the answer will be like not very exact, right? So plus minus lah, okay? If you get negative 3.2 to 3.3, good enough. 1.2 to 1.3, good enough. Okay? Because I think sometimes when we draw graphs, sometimes the shape might be a little bit different based on how we draw the curve, right? Yeah. Okay, but it should be around roughly these values. If you get like negative 2, positive 2, then of course too far off. So that will be wrong. Okay? So yeah, if you manage to try this question, take a look at this last part. I think this is the most important part that you need to try. Okay? And if you can get this answer, you're good to go. Okay, I think most questions at most they change things like what they give you for the function, or maybe they change the equation slightly. Maybe you need to draw some other different kind of line, right? But the idea is always like this: make sure you squeeze out the original function that you were dealing with at first. Everything else throw to the other side. And that's it. Then everything else I think is quite simple. So yeah, that's all I have for today. Okay, that's all I have for this video. And hopefully this helps in your revision.